I thought this would be an interesting problem to work through. A student asked a question about it. I pulled the answer up. It's all screenshots here. So a spring oscillates with a frequency of 6 cycles per second. So key terms here are frequency of 6 cycles. Its initial displacement. So this is also key in telling us if it's going to be a sine or cosine function. So it's displaced 2 centimeters. So that means it's going to be up. So let's say this is a 2. It's going to be up here to start. So when x is 0 or t is 0, sine would have started down here, and then the cosine starts up high. So, and the 2 gives us our leading coefficient, and its damping factor is 0.4. So we're not sure what that is. So let's go through. I did a screenshot of some of the book's materials. So give the function, f of t that describes the position of the spring t seconds after it starts oscillating. So this is for simple harmonic motion here. And what I wanted to point out is, you have d equals a. A is that amplitude. And so, we're talking about the 2 in this case. So that's a would have been 2. But this is not a one that's damped like this next part. But then we have omega t. And so it's either cosine or sine. What I want to get at is this part right here. So the key thing I want to point out is that this is the frequency. That when we have a frequency, we set it equal to this. So our frequency would be equal to omega over 2 pi. So that our frequency is going to be 2 pi. So our omega is 2 pi times the frequency. And we use that number as the coefficient of t. Excuse me. And that's the same thing down here. Now, we see, okay, I think that's good to leave there. Let's go down to the general note for damped harmonic frequency. So that gives us the 2 formulas to work with. We've already decided we're going to go with the cosine because it starts up higher. Right, so starts up there. And we know our A, because that's going to be 2. And here's the new thing. We know what our omega is going to, we will find the omega in just a second. So I repasted it down here. And the big thing is, what is the C? Well, it says that C is a damping factor, and it gives us our damping factor is 0.4. And so that's where this is coming from. So what we have is, let's go with our frequency. It says our frequency is 6. So 6 equals omega over 2 pi. So omega is 6 times 2 pi, or 12 pi. So we put this all together, and our f of t is going to be the 2, as we talked about, because it has an initial displacement of 2. E to the negative 0.4 is our damping factor, times t, times cosine of omega, which is 12 pi t. And I know some of you are saying, oh, it's a w. Well, it's a lowercase omega. And then this would be our solution, or not a solution, but that's our formula, which is what we see there. And that's how we get that. Hope that makes some sense. If it doesn't, please let me know. I'll be happy to try to clarify some more.